Hello, Algebra 1 students, and welcome to Lesson 4.1 covering solving systems by graphing. So in this topic, you've seen we've kind of gone out of order. So we started with 4.2 on substitution, we then did 4.3 on elimination, and now we are teaching you 4.1, which is on graphing. Now, the reason we're doing graphing is because once we teach you this, Desmos can be your best friend for solving a system. So unless it says solve by substitution or solve by elimination, I would suggest use Desmos moving forward. Now, let's think about the problems we've done thus far. When you have solved a system, the answer has been an ordered pair XY. The reason that it's an ordered pair is because graphically what these two equations represent are two lines. Line 1, line 2. And the solution that we're looking for is the intersection point where those two lines cross. So this point right here is called the intersection point. Interpoint. And that point has coordinates of x and y. And that is the solution we're looking for. So today we're going to start by graphing one by hand, but then we're going to move on to using Desmos to solve these systems by graphing. Okay. First problem here. What is the solution of the system of equations? So let us graph this set of equations. So let's recall that these two equations are in slope-intercept form. So slope-intercept form, y equals mx plus b. Remember that when you graph an equation in slope-intercept form, you start with the b, that is the y-intercept, and then you count the slope, and that gives you your second point. So in this first equation, your b value is a negative 4. That means we're going to go down 4 on the y-axis. 1, 2, 3, 4. Then we're going to count the slope. And the slope of this line is a negative 2, the number with the x. Make it a fraction by putting it over top of 1. And now that is your rise and your run. We're going to go down 2 because it's negative, and always to the right 1. So down to right 1. Keep counting. Down to right 1. Now let's go back to our y-intercept. Let's go the other way. Let's go up to left 1. Up to left 1. Up to left 1. And there we go. And there's our first line. Okay. Again, in order to get a good picture, it's good, if you're doing by hand, to get a good picture, count the slope many times. So now let's do the second line in blue. So the b value is positive 6. That means we're going to go up 6 from the origin. 1, 2, 3, 4, 5, 6. And now our slope is 1/2. That is up 1 and always to the right 2. Up 1, right 2. Up 1, right 2. Go back to your y-intercept. Go the other way. Go down 1, left 2. Down 1, left 2. And look at that. If you graphed it like I did, my first line was now touched by my slope counting. I'm going to do down 1, left 2 again, and I'm going to connect those dots with a line as best I can. Oh, it's bad on the last one. And now I have found my intersection point. I'm going to put it in purple because that's what blue and red make. They make purple. That point is my answer. So from the origin, I count left 4 and up 4. Left 4, up 4. There is the answer to this problem. The answer to this system is negative 4, 4. That is the point where these two lines intersect. So moving forward, I hope that you just use Desmos to graph these, and we're going to show you how you click on Desmos, to find the point of intersection. Okay? Next. Okay. Solve this system. So again, I have these two equations by my side. You have them on your paper. I'm going to go to Desmos and graph these. Now, when we go to Desmos and graph them, we have to find nice points on the graph so that we can graph these on Savvis or on a piece of paper. So let me show you what I mean. So here's Desmos. Now when you go to Desmos, do you see how it counts by 0s and 2s? Don't do that. Zoom out one time so it says 0 and 5s. Now every box is worth 1. Just makes it easier. So the first equation, 15x plus 5y equals 25. Okay, so there's that line. It's in red. If I click on these gray dots, these are the intercepts. These are the points that I would use. So 0, 5 is 1, and oh, bummer, this is a decimal. You can't use that. You can't graph that decimal on a picture. So you need to find another nice point to use. Now I see two of them. I see one right there. Notice I'm clicking and dragging, so I see 1, 2, or one down here at 2, -1. You can use whatever you want. I'm going to use 0, 5, and 2, -1. So for this line here, I'm going to use 0, 5, and 2, -1. So I will graph this with you back on the slide. Okay, so let's do the second line. So for the second line, it is y equals 5 minus 3x. Notice I'm not changing a thing. I'm just typing it exactly as it looks. And weird, where'd the red line go? Now it's only in blue. Well, look at this. If I click this like blue little squiggle, oh, the blue and the red line are what we call coinciding. They're the same line. So I'm going to use the same 2 points to draw that line. Okay, so let's go back to our picture and talk about this, right? So 0, 5, 2, -1. So I'm going to grab my thing. I'm going to start with red. I'm going to go 0, 5, 1, 2, 3, 4, 5. Put a dot there. And then 2, -1. 2, -1. Okay, so there's the first line. And again, just connect them as best you can with a straight line. Now for the second line, I'll use blue, but it's the exact same line. So it's going to be right on top of it using the same exact 2 points and connecting them as best you can with a straight line. So in this picture, I'll use purple, these 2 lines are the same. Same line. When your 2 lines are the same, that means that they intersect everywhere. And if you think about those special solutions, if they intersect everywhere, that's going to be infinitely many solutions. Okay, so be aware of this special case when it comes to graphing. Okay, let's do one more in this video. Okay, so now let's graph this one. So we can have my equations. I'm going to go to Desmos right now. Delete these 2. All right, so the first one here, I have y minus 2x equals 6. Okay, if I click on the gray dots, let's change this. No, it's fine, it's green. It'll be my red graph. So -3 and 6. So -3, 0, and 0, 6. So again, I'm going to put in red because that'll be my red graph. So I have -3, 0, and 0, 6. Okay. The second equation, -4x plus 2y equals 8. Okay, so it's a separate line this time. It's in purple. I'm going to use blue when I graph it. Okay, if I click on the 2 dots, 0, 4, -2, 0. So my 2 points are -2, 0, and 0, 4. Now notice, and we'll talk about this when we graph it, but notice how those lines interact. All right, so let's graph it. Okay, so let's go back to our paper here. Okay, so the first one I'll do in red was at 0, 6, 1, 2, 3, 4, 5, and -3, 0. Okay, so that's my red graph. The second one here is at 1, 2, 3, 4, and -2, 0. Now, if you look at those 2 lines, they don't look like they touch. If I asked you to describe those lines, I hope that you would use this word, I'll put it in purple, called parallel. Those 2 lines are parallel. If parallel lines do not touch, then they do not have a point of intersection. And if they don't have a point of intersection, then the answer is no solution. Okay, so this is the end of the first video covering how to use Desmos to graph. The second video coming up is going to be a word problem. All right, so continue watching the second video.